Here we are in lesson 512. And hopefully this actually records this time. Did you know that on YouTube you can only download a 15-minute video? That's why none of you could find it on the internet last night. However, what I would like you to do is start with his math notes box on rational functions. There's a definition there on rational functions. This is the topic that we talked about in Algebra 2. I want you to recall a graphing form of a rational function. In this case, y equals a over x minus h plus k, where h is a horizontal shift, k is a vertical shift. That's something that you should already know coming into this course, something that we practiced in Chapter 1, something that we're going to take a look at again today. Alright, so we're going to start with problem 5-14. That's 5-14. And in problem 5-14, they're asking us to take the number 20/17 and rewrite it as a mixed fraction. This is sort of like the 5th grade version of what we're going to do today. Okay, so 20/17 is a mixed number. One useful way to do this, and probably the very first way you were shown to do this, before you were shown how to use a calculator, was to take that, copy your denominator. That's always step one. Doesn't even matter when we throw x's in there. That's always going to be step one. Okay, and then also copy your denominator in the numerator. Okay, just write it there. Doesn't matter what it is, write it there. Okay, then you got to ask yourself a question. What do I need to do to that numerator to maintain equality? The key there is to maintain equality in the numerator. So what do you got to do to 17? Okay, so that the numerator still equals 20. We got to add 3. Good answer. So plus 3. All right, that's where we want to be. Because once we're in that step right there, we can take our fraction and we can divide both of the parts of the numerator by the denominator. So we end up with, say, 17 over 17 plus 3 over 17. The plus symbol's still there. We didn't change that. Now, what is the reason? Why did we want to do that? Well, we wanted to do that because 17 over 17, everybody in here should know, equals 1. Okay? Plus 3/17, so 1 and 3/17 there is your mixed number. Now, we're going to be able to repeat that process with variables. So let's take a look at number 15. Okay, some rational functions look complicated, but are not. They are simply shifts of f of x equals 1 over x. We want to look at these cases. So letter A asks us to sketch f of x equals 1 over x on a set of axes. Okay, it is a sketch. This is 5-15. So I'm just going to give a quick set of axes here that we'll use for a few problems. All right, you obviously would want to be doing the same thing right now. Okay, I'm going to make it a little more accurate than I usually would, just so I can reuse it a couple times, hopefully. All right, so if you need more time than that, then go ahead and push pause and do what you got to do. Okay, so there's my axes. I'm going to try to use a bunch of times. Okay, if I wanted to graph f of x equals 1 over x, that's the parent graph. And I always want you to start here. You're always starting with an HA and a VA. If you remember, this graph was the first time we really experienced the whole HA-VA thing in Algebra 2. Okay, and if you forget what that parent family name was, it was a hyperbola. Okay, we're talking about a hyperbola, not a hyperbola. Okay, it's not a bola full of energy. Okay, and then part B says to sketch 1 over x plus 2 plus 3, right? Plus 2 plus 3, yeah, sure. Okay, so if you recall, all right, 1 over x plus 2 plus 3. Again, first step is still HA-VA. All right, this plus 2 is a left 2, and that is an up 3. Okay, so I'm going to take this VA, I'm going to move it left 2, and I'm going to draw a new VA. Okay, I'm going to take this HA here and move it up 3. I'm going to draw a new HA. And for those of you who have gotten good at this, or got good at this in Algebra 2, you're sort of just moving the x and y axis. So this is where we're working from now, and I'm still drawing a hyperbola. Just like that, which is a shift of the original. Okay? But again, always start with the HA and the VA. They are the first two steps. Once you have the HA and the VA, drawing a hyperbola is nothing more than, doing a little loop-de-loop on each side. Okay? All right, then 5-16, we're going to take a look at how these two are related. How does graphing these and what we did in problem 14 relate to one another? I'm going to erase this. If you needed it, you're going to have to rewind. Try to be as close as possible here so I can reuse these axes, hopefully. Okay. Now, I'm looking at problem number 16 in your book. All right, 5-16. And they're giving us the equation y equals x plus 2 over x minus 1. Now, the whole point of this lesson is to take this and convert it to graphing form. Because right now, we can't graph that. I mean, we can with a calculator, but we want to be able to do a quick sketch by hand. Okay, so we want to take this and we would convert it to graphing form. Now, if you recall the very first problem, number 14, I told you the first step is always the same. And I didn't lie. Okay, the first step's always the same. First step, write the denominator. Just put it there. It's not going to change. The second step, again, doesn't change. Step number 2 is always write that denominator in the numerator. So I'm going to write an x minus 1 in the numerator. And now I need to ask myself, how do I make an x minus 1 equal an x plus 2? Well, I already have the x. Okay, so that part's equal. So how do I make a minus 1 equal a plus 2? Well, all you geniuses out there, let's add 3. Because negative 1 plus 3 is positive 2. That would have x plus 2. Now remember, the reason we did that is so we can take that statement and divide both parts of the numerator by that denominator. What we end up with here is x minus 1 over x minus 1 plus 3 over x minus 1. What's the advantage? Okay, what's the advantage? Well, the advantage is, we learned way back in 3rd grade, anything divided by itself is always 1. So we end up with 1 plus 3 over x minus 1. So now when I look at that, you can tell me 2 shifts that have to happen. I have to go right 1, and I have to go up 1. So if I go right 1, up 1, now the stretch of 3, that's a little tricky to sketch, all right? But that's why it's called a sketch. There you go. That's problem 5-16. Part A. All right, that was 5-16. Okay, 5-16b. Use a similar technique on h of x, which is 2x minus 5 over x minus 3. Now this one's a little trickier. Okay, I'm going to leave this work up here so we can refer back to it if you need to. And I'm going to kind of move this direction a little bit. Okay? So, 5-16b. And now I'm talking y equals 2x minus 5 over x minus 3. Look, the first step is always the same. So do it. Write the denominator, x minus 3. Second step is always the same. So do it. Write the denominator in the numerator, x minus 3. Now you've got to ask yourself, how can I make that x minus 3 equal to a 2x minus 5? Well, first of all, you should notice that x is being what? It's being multiplied. What's it being multiplied by? It's being multiplied by 2. So I've got to multiply it by 2. When I do that, I have to use parentheses. Okay? Now when I multiply by 2 there, I'm going to have 2 times x. I'm going to have my 2x. That's good. But then I'm going to have 2 times negative 3. What does 2 times negative 3 give you? Yeah, it gives you negative 6. I don't want negative 6 though. What do I want? I want negative 5. What do you have to do negative 6 to get negative 5? You got to add 1. All right. Once we have that, again, the process stays the same. I can now divide both sides or both parts of my numerator by the denominator. All right. So I end up with 2x minus 3 over x minus 3 plus 1 over x minus 3. Okay? The advantage, again, advantage here, x minus 3 and x minus 3 do what? They cancel each other out. What am I left with? I'm left with 2 plus 1 over x minus 3. So now this graph here that without a calculator I would have been able to sketch. I can now sketch. And our 10 minutes is up, so I'm going to start a new video. You're going to have to go to part 2.